Hi guys, this is your DK again. In this video, we are going to see how to perform custom object detection using YOLO NAS. YOLO NAS is the new YOLO architecture which has been introduced by Daisy AI, which has been outperforming other YOLO models which has been released till date. Now let's jump into the demo. First, let us see the training images which I'm going to use for the model. So I have an image of a banana and a water bottle and a mango. So let me show the sample images which I have picked. Since this is for the demo purpose, I have picked just 10 images of each and every labels. So if you look at the bottle, I just have some around 5 images, and mango I have something like around 5 to 6 images. Our primary objective is to predict whether a fruit is present in a particular image or in a video. Now let's do how we can do that. For that, we need to annotate the data. RoboFlow is an open source annotation site which we can do free of cost. For that, you need to create an account over here. Already I have an account, so I have logged in into my account. So I'm going to click on a particular workspace and I'm going to create a new project. So you need to click on this new project over here. When you click on a new project, it asks for the type of project. So you need to select object detection bounding box, because we're going to draw the bounding box on the image. If you're not sure what I'm speaking about, you will get a clear understanding at the end of the video. So you need to give a name for the project. So let me give like fruit detection, something like this, detection, and project name. What you are predicting is a fruit detection. Again, the project name is going to remain the same for me. So I'm going to use the licensed one, CC by 4.0. You can leave it as default. I'm going to create a public project over here. Once this is created, I need to upload all the images. So let me go and upload all the images. Okay, so I'm going to upload the image of banana over here. Let me open it. And once it is uploaded, let me select for other thing, which is a mango, all the images of mango. And okay, so .avif file is not supported, so it will ignore automatically. We don't want to worry about it. Let me select an image of bottle. The reason why I have three different images is like when you try to train a particular image or a particular label, the model is throwing some error. So I have kept some three different images and three different labels in order to avoid the error. I have even reported the same to the official site. I'm yet to get the answer on it. If I get an answer, I will share the same to you. You need to click on save and continue over here. Once you uploaded all the images, you need to click on save and continue over here. So it is uploading all the images for you. Okay, great. Now all the images has been uploaded. You can invite your friends for the annotations. Since I'm going to do all the annotations by myself, I'm going to assign it to me. So you can, if you have friends, you can add their email ID and you can invite the team and you can assign images. Since I'm doing by myself, I'm going to assign everything to me. So I'm going to give on assign images. So everything is been assigned, so I need to start annotation. So what is annotation is like, so we do have a image, right? In that image, our object is going to be in the particular position. So you need to draw the box like this. When you draw a box like this, it will ask for the label. So you need to type something like banana. So basically it says like in the whole image, in this particular box, my image is present or my object is present. It gathers the coordinates of x1, y1, x2, y2 of this particular image and creates a label. I will show you the label while we go on with the demo. So I need to save and enter, and I need to select second one. So here I need to crop where my banana is present. It's banana, save and enter. Next, I'm going to do the same for each and every image. Banana, save and enter, and next. Again here it's banana, save and enter, and next. Okay, you need to have a different combination of images. At least you should have minimum of 100 to 200 images for some kind of accuracy. Since it's a live demo, I just picked some 10 images. I'm not bothered about how accurate it is. Let's see how the model predicts with some number of images. Okay, I'm just gonna now it's a mango, right? So you need to select this particular image and you need to label it as mango. So it will automatically, you can see, right, banana is already present. When I click and save and enter mango, it is gonna label this as mango over here. So if you have multiple labels also, you can mention it. So like this. So mango is present over here. Okay, now the labeling is done. Once you have done with the labeling, you can click on the back arrow. It will go back and you need to click on this one, add 20 images to the data set, and you can choose an option like split images between train, valid and test. It default splits into 70-20-10 ratio. If you want to assign everything to single training set, also you can do. I'm gonna split based upon the images, and I'm gonna click on add images. So basically what it will do is like it will split the images into train, test and everything, and it will assign everything to me. Once annotation is done, you need to click on the generate. Here we do have some kind of default pre-processing step. If you want to add the pre-processing step, you can add it like grayscaling everything. I'm not bothered about it. I'm gonna keep the default pre-processing step, and I'm gonna click on continue. Next on augmentation, if you want to add some augmentation like cropping, if you want to do, you can do it. Even I'm not worried about it. I'm gonna keep the default one. And what I'm gonna do is like I'm gonna generate it. So basically it is going to generate a data set for me. Okay, it is generating. Okay, so I need to export the dataset. You can click on the export dataset. So basically which file format you want. I'm going to select YOLO v5 and click on continue. So it will give you some code base over there. You need to copy that code base and you need to paste it in your local machine. Let me copy paste in my local machine. Okay, now we have done with our dataset labeling. Now let's jump into the coding part. Yeah, now let's start with the training. For that, we need to enable the GPU version. You can click on the edit and you can go to the notebook setting and you can select the GPU over here, and default T4 is been enabled for us as a free tier version. You can select on the T4 and click on save over here. So this is used to check whether the GPU is enabled. Okay, now the GPU has been enabled. I can see the same over here. Now let's try to import some of the basic packages which is needed as part of our implementation. Okay, now we have installed all the packages which is needed for our coding. Then we need to click on the restart runtime. So once we have clicked on the restart runtime, now let's try to set some of our directory path actually. So I'm going to set the directory path as home, and we're going to see whether GPU is enabled. Then we're going to use the GPU, and I'm going to use the default model architecture name as YOLO NAS. Let me run this piece of code. Okay, this is done. So let me try to import the default pre-trained model. This is the piece of code which is doing it for me. Now it is working fine. Already we have prepared our dataset in the RoboFlow. Now I need to import the RoboFlow dataset into my Google Colab. Let me write a piece of logic for this. So if you remember, this is the piece of code which is given by my RoboFlow. So basically it integrates to my RoboFlow using my API key and gets the project images which I have created in my RoboFlow. When I run this piece of code, you can see the folder is getting created over here. Let's see. Okay, the folder is getting got created. Let me refresh it actually. Yeah, you can see right, fruit names -3 is the project, and you can see the images over here. It is split into train, test and valid. Let me open any one of the things. So let me open the test. So for this particular image, when I click the image is getting opened over here. For this particular image, if you go to the label, there will be a label file which is present. So you can see right, the name of the image and the label file matters. Only the extension differs. When I click on this one, so basically this is the bounding box. X1, X2 and Y1, Y2. Similarly, you can see for the other image. If you click on this one, for this particular mango, there is the mango present. So I annotated for 3 different mangoes, right? If you click on this one, right, you can see the label is set to 2, and for the each and every 3 images of the mango, the coordinate has been marked over here. So let me close this file, which is not needed for me. Now I have imported all the data which is needed for the training purpose. Now let me define some of the parameters to mention where my data is present. So if you see here, I'm just mentioning location. Location is like dataset location, which is fruit underscore names, and the labels. So if you look over here, we will have something like YAML file. If you click on this YAML file, it will show like basically this is my train image location, this is my test image location, and these are all the labels I do have. So it will have the high level information over here. So I'm just setting it over there. So if you see here, train images is where all my train images is present. Test image is where all my test images present and corresponding label is present. Location is the location of the path where my image is present, and labels, all the four labels. So let me run this piece of code. So you can see, right, classes is banana, bottle, mango, and mosquito. This is what I'm gonna do. And content root hyphen name underscore free is where my all the data is present. So now let me define some of the trainable parameters for the model to train. Let me explain the same for you. You see here, I'm gonna keep the batch size as 8, and I'm gonna have a epoch as 25, which means 25 times it's gonna do the forward and backward propagation. And once the model is trained, I want to capture the model or the trained model in this particular path, which is not created till now. It will get created during the runtime. So if you see here, I'm gonna use the default train model, and I'm gonna train the model based upon the dataset.data directory which I have defined over here. So basically, it takes this particular path of train images, test images, and it's gonna train the data for me. I'm just setting the parameters over here. So let me run this piece of code. Once the parameter is set, now I'm gonna set the hyperparameter tuning for this particular parameters. So when I say hyperparameter tuning, I'm going to set the threshold to 0.7, which means if it is crosses the 70% of accuracy, then predict it as a particular class or not. I'm going to pass the epoch, which I have mentioned over there, and I'm going to pass the default learning rate and other details over here. Let me run this piece of code. Okay, this is run. So basically trainer.train. This is the code which is going to train the model. So it's going to take the test data, train data, valid data, and it is going to apply the YOLO NAS model, and it's going to train the data on my custom data set. Let me run this piece of code. Here I have given the epoch as 25, so it will run for quite a long of time. So we need to wait for some time for the model to get run. We'll wait for some time. Yes guys, now the training has completed for the 25 epochs. Now let's see what has done over here. You can see the checkpoint directory, right? In the checkpoint directory, for each and every model, it has printed it has logged the model. So we have average model and the best model and the latest model. Now let's check the best model, how it is performing good. So what I'm going to do is I'm going to get the model. So we have trained the model and we have kept the model over here. I'm going to pick this model which we have trained actually. So here I need to change the name to ckpt underscore best, which means I'm going to take this best dot model. Let me run this piece of code. So it is going to take this best model for me. Okay, now what I'm going to do is I'm going to upload an image. Let me try to upload an image. Let me show you the image which I'm uploading. Okay, so this is a demo image which I have kept for uploading purpose. It has demo image has been uploaded. Let me click on this one. So this is the demo image of a banana. So let me try to predict this image, how it is working fine. So let me copy paste the code and let me show you. This is the code. Okay, so using the best image, I'm going to pass this path. Let me go here and copy path and let me paste the path over here. So when I paste the path over here, okay, let me run this. Okay, now it is able to predict it as a banana. So it is predicting it as a banana with 54% of accuracy. It's well and good. It's not predicting mango. That's a good improvement for me. Now let me try to upload a video actually. Let me see how it works fine in the video. Let me upload a video. Give me a minute. So it is getting uploaded. Okay, the video got uploaded. So we have uploaded a video, testing video MP4. Let me copy the path actually. So this is the code to test the video. So what I'm going to do is I'm going to read the video. I'm going to perform a prediction like best model to device, and I'm going to predict it based upon the input video. Once I predict it, I'm going to save the video in the output video path. Here you can see the detection.mp4, which is not currently present over here. Let me show you the raw video which I'm going to test it actually. So this is the video which I'm gonna play. Where it is, testing video. So this is the video I'm gonna detect actually. So here I have a mango placed over there. So now let us see how my model is getting gonna predict it. So let me run this piece of code. This is the video I have uploaded. So let me run this piece of code. Okay, it is predicting and it is printing the same. I mean, which means writing the same in this particular path. Reduction.mp4 it has written. Let me refresh it. You can see the video over here, reduction.mp4. Let me run it. When you double click it, the video will download and it will automatically play. Yeah, you can see over here it is predicting the mango as a mango. So that's it with today's videos, guys. Thanks for watching the video and happy learning.